All right, so the first thing, all right, and you'll notice that, and you never get this on a quiz or a test, but and Addie, since I see you here, can you give me a thumbs up in the camera if you see what I'm looking at here, the falses? Okay. So you would never get five false answers in a row on a quiz or test. You'd start freaking out. But let's go through this. So when a battery no longer works, it's not that it's run out of charge. What it has run out of is out of energy. All right. And the lab that you're going to be playing with, the one that's posted today, is all about understanding that what the battery does is it does not make charge. It simply provides the charges with some energy. And I think all of us maybe are feeling a little low energy with the weather that we've been having. But that's one common misconception. It's not that we run out of charge, we run out of energy, which is why if you have a rechargeable battery, you plug it into the wall, and lo and behold, you end up with more energy. All right. B, and if at any point you have a question about these, just jump in and ask. B, battery is a source not of charge, but it's a source of energy. We already touched on that a little bit. C, charge becomes used up as it flows through the circuit. The amount of charge that exits a light bulb is less than the amount that enters a light bulb. No, and I'm hoping that maybe one of you guys could point to some evidence that we have that tells us that it's the same amount of charge everywhere in the circuit. I'm going to throw it open to anybody. Chime in there, somebody. How do we know it's the same amount of charge everywhere?
The current
Like,
stays the same
All right, I think I heard Kate. Kate, go ahead and finish it off there.
because the current stays the same.
Yeah, we put the current, the ammeter, in lots of different places in the circuit. Thank you guys. And we saw that it was the same amount of charge per second. So charge doesn't get used up. What actually does get used up is the energy. And that's one of the things you'll explore in the lab that's posted today. Okay, we've not talked about this one. D, charge flows at very high speeds. It actually doesn't. It travels very moderately, kind of like a slow walking pace. And the reason is simply this: the battery is the pusher, but what it's pushing are electrons. And those electrons have to navigate their way through a wire which is filled with other electrons. So there's a lot of banging and collisions, and it's not a straight line, steady process. But the general trend with the direct current circuit is all in one direction. And as those electrons all bang around inside of the wire against each other, they actually move pretty slowly. The reason that light bulbs light up at the same time is because, as we talked about a while ago, the charge is already in the circuit. The charge is already everywhere. So as soon as you throw the switch, you put the battery in, you're simply giving the charge a reason to move. With E, Dominion Power doesn't supply us electrons, they supply us energy. All right. The electrons are already in the wire, but they're not doing anything until we connect up and we complete that continuous conducting path. And then the energy that Dominion Power is giving us, we can harness it for our electrical devices and all that stuff. So I wanted to give a quick run through of that. Any questions about those? Because that was where I saw most of the issues. I have posted answers, so you can check those. All right. So I'm going to stop screen sharing there. I'm going to stop recording if I can figure out